start. Okay, last time we started chapter 6, talking about the first type of nitrogen-containing compound we're studying in this chapter, called amines. Okay, what are amines? Amines are basically derived from this inorganic molecule called what? Ammonia. Ammonia has a nitrogen with 3 hydrogen bonded to it. If we replace any one of the hydrogen, at least one, with a carbon group with an R, what we get is a what? Is an amine. Depends on how many R's are replacing the hydrogens. We have primary amine, secondary amine, and what? Tertiary amine. Okay, those are what we started last time. And you notice that no matter the inorganic ammonia or these organic amines, the nitrogen contains what? 3 bonds. Is that right? And besides that, you also notice that the nitrogen has a pair of electrons. We call that non-bonding or lone pair sometimes. Lone means lonely, no, lone pair means they're not involved in bonding. And that pair of electrons in all these molecules, you can see basically they're the same. The only difference is how many hydrogen, how many R groups are bonded to it. But the nitrogen itself, they're very similar property-wise. And due to that lone pair electron, a pair of lone pair electrons, amines, including the inorganic ammonia, are basic molecules, or are bases. They are bases. Base is a word in comparison to what? To acids. Okay. Why they're bases? Because when you dissolve these molecules in water, okay, any of those in water, if they're soluble in water, the nitrogen, regardless what type of nitrogen, you can say no matter your primary, secondary, tertiary, the nitrogen is the same. The nitrogen will take a hydrogen plus from water. When you take a hydrogen plus from water, NH2 in this case, this is a primary amine, NH2 becomes, take a look, NH3 plus. You guys see that? And of course, when water is losing a hydrogen plus, water becomes what? OH negative. And because of this property, because of this reaction, we define amines bases. Why they're base? They can take a hydrogen plus, right? Something can take what is hydrogen plus? We learned before. Hydrogen plus is what? It's an acid, right? Any acid gives hydrogen plus. So anything that takes an acid is a what? Is a base. Or another definition, this guy in water can generate what? OH minus. What is OH minus? It's also a base. Hydroxide is a base, like sodium hydroxide, potassium hydroxide, they're bases. And because of these reasons, amines are base. Does it make sense? Now you take a look at the nitrogen here. How many bonds do you think the nitrogen has now? We know these all have how many bonds? 3 bonds, right? Take a look at this nitrogen in the product. How many bonds? Take a count. How many bonds? You have how many hydrogen here? 3. And a what? And a carbon. Is that right? How many bonds? 4 bonds. Nitrogen can have 4 bonds. But when nitrogen has 4 bonds, nitrogen will have a what? Positive charge. Why there's a positive charge? Because nitrogen used that pair of electrons to make a bond. You may wonder why nitrogen have an extra bond? Because nitrogen has a pair of electrons that can make a bond with what? With the hydrogen plus. They give the electron out to make a bond. That's why nitrogen now has a positive charge. Do you guys understand the reaction? Why amines are bases? Because they accept a proton. Again, we call hydrogen plus a proton. From what? From water. You end up with these 2 products. N becomes N plus. Of course, you need to add a hydrogen on it. NH2 becomes what? NH3 plus. And what? OH minus. Where does the OH minus come from? From what's remaining from what? From water. Does it make sense, guys? Okay, take a look at these two reactions. I think will both make sense to you. They both make sense to you. This one is a primary amine again. NH2 takes a hydrogen plus from water. NH2 becomes what? NH3 plus. Water becomes OH minus. In this case, you have to spell out both species. Okay, they're spelled both species. They're actually together. Plus and minus, they're actually staying. You can put them separate together. It's the same. Okay, the bottom example. This one is a what type of amine? Tertiary amine. You guys see that? 3 groups. Tertiary amine. And tertiary amines with nitrogen is what? Is N. Nothing. No hydrogen at all. But it said the same. Because the reaction is happening on what? On the N. Okay, it doesn't matter how many groups you have. On the lone pair of the N. So N now becomes what? NH plus. And the same water will become what? OH minus. Easy? Okay, this is again the reaction. If you want to ask what is the reaction called? This reaction is the reaction of amines with water. The reaction showing why amines are again bases. Make sense, guys? Good? Okay, next. Okay, next. Also, easy. Okay, if you understand that reaction, you will have no problem understanding this reaction. We know amines can take a hydrogen plus from water. Then amines can easily or more easily take a hydrogen plus from an acid, such as hydrochloric acid. HCl stands for hydrochloric acid in water. Okay, when amine take a hydrogen plus from acid, nitrogen becomes nitrogen plus with one more what? One more hydrogen. Is that right, guys? And HCl becomes what? Take a look. Cl minus. Is that the same? Okay, the difference is previously is with water. This one is with what? With an acid. Okay, with an acid. Okay, this is a primary amine. NH2 becomes NH3 plus Cl minus. You can see that you can spell them all like together because positive plus charge they will stay together. You can put a plus between these two, like this one and that one, or spell them together. They're both correct. If you see them, they're both mean the same thing. Okay, you can spell them out again, the plus species with the minus species, or put them all together like a side by side. And by the way, this is also called a salt. Okay, a salt. Why is a salt? Because it's the product from an acid and what? And a base reaction. Okay, this is an acid, that's a base. The product will be a salt. Okay, the bottom example is a secondary base. You can see that secondary amine. NH becomes what? NH2 plus and Cl becomes what? Cl minus. Make sense? Okay, those are the two reactions. Okay, two types of reactions showing why amines are basic. Okay, amines are basic. And finally, when nitrogen with 4 bonds and charged, the resulting ion, the plus ion with the nitrogen like this, we give them a name called ammonium ion. Okay, ammonium ion, the charged species. Okay, I think I may have the word somewhere. I didn't point it out. Here. Ammonium ion. You can see that? What is ammonium? A charged nitrogen with 4 bonds. And the ion, the plus ion, okay, anything with a charge, we call it an ion, is called an ammonium ion. Okay, ammonium ion. So that means when amine react with water or an amine react with an acid, they both result in what? Ammonium ion. Okay, ammonium ion. Difference is reacting with water, the other ion is either OH minus or what? Cl minus from the acid. Depends on what you use. to react with the amine. Any questions, guys? Does it make sense? These two reactions? Good? All right, let's take a look. Ammonium ions or ammonium salt are also extremely useful in pharmaceutical industries. Because like I mentioned earlier, a lot of medicine or natural products with biological activities are nitrogen-containing compounds. After you convert an amine that is not soluble in water to an ammonium salt, the insoluble medicine can be converted to something extremely water soluble that can be more widely used, okay, such as, again, IV. Okay, the top is a very good example showing you guys. You guys will probably use that a lot in your future. Okay, this is the structure of morphine. Okay, it doesn't dissolve in water. It's a very large molecule. It doesn't dissolve in water. Okay, you can see morphine is a tertiary amine. Do you guys see that? This is nitrogen over here. It's a tertiary amine. It doesn't dissolve in water. So in pharmaceutical industry, in common practice, they treat morphine with sulfuric acid. This is sulfuric acid. To convert the N to what? Take a look, guys. NH plus. Do you guys see that? And after that, morphine becomes morphine salt, morphine sulfate. Okay, if you have a bottle of morphine, you will see that actually is given as morphine sulfate. Because this guy is very water soluble now. Okay, besides that, if you have a box of medicine, a box of IV medicine especially, you can make a solution. If you see the name has sulfate, or like this one, hydrochloride, this is oxycodone, hydrochloride. Okay, if you see that, most likely they are what? Ammonium salts. Why they have a hydrochloride or sulfate there? Because they treat those with what? With an acid. Okay, with an acid. What is hydrochloride? This one is hydrochloride. When you treat with an acid, this one becomes hydrochloride. The same idea for oxycodone. Okay, oxycodone. Okay, if you see the label contains these names, they are ammonium salts. And by the way, have you guys watched the show? Is that not HBO? What's that? Hulu, from Hulu channel. It's an eight episode show about oxycodone. The past 20 years, by Purdue Pharmaceutics, they invented this evil painkiller, and like a haunted 20 years of the past 20 years of the United States. A lot of people got addicted by this. There was no regulation on this before. Okay, nowadays it's very heavy regulations on this. Okay, don't if you don't have to, definitely don't take this. Okay, it's more addictive than you think. Okay, if you don't have to, definitely take this. I was prescribed many times. I threw them away. I mean, if you need a painkiller, if ibuprofen or Tylenol can solve it, never take these if you don't have to. A lot of people's lives got ruined by oxycodone. It's more harm. Watch the show. It's a very good one. Hulu, 8 episodes. It's very dramatic, showing you how the big companies, for money, what they did for this one, for the past 20 years. Now, once you have an ammonium salt, okay, like this one. Okay, this is a hydrochloride, again, treated with an acid. How do we convert it back to the original amine? Or how does the biological system convert it back to? Remember, if you're taking morphine or whatever, you're still taking it as ammonium salt. So what if we want to convert it back to ammonium, like the original amine? The easiest way, of course, is treat the ammonium salt with a base. Okay, treat the ammonium salt with a base. Take a look at this structure. When you see nitrogen with a positive charge, hydrogen with some hydrogen with a positive charge, what does it mean? It means amine with a what? With a hydrogen plus. Is that right, guys? No matter the hydrogen plus is from water or what, from an acid, but it has a hydrogen plus on it. Is that right? So what can take a hydrogen plus away? A base can take a hydrogen plus away, such as sodium hydroxide, for example. Of course, this is a strong base. So when you treat with a sodium hydroxide, the OH minus here can take what? Take the hydrogen plus away. So NH3 plus can go back to what? NH2. Does it make sense? So when you look at structure like this, your mind, you know, oh, this is a nitrogen that has a what? Has an extra hydrogen plus on it. Does it make sense? Now, how do we take hydrogen plus away again? Using a base. Of course, in our biological system, we don't use hydrogen sodium hydroxide. We have a buffering system that can remove that hydrogen plus in our physiological condition. Under physiological, milder, much milder condition than treating with a sodium hydroxide. Here, I'm just showing you the reaction. What can be done? Okay, to remove that hydrogen plus to turn the ammonium salt what? Back to amine. So here is what we have learned so far. Okay, if you understand these two conversions, you pass this part of this lecture. Treat amine with an acid, with hydrogen plus. Again, the hydrogen plus can either be from water or what? From an acid. You can change the amine to what? Ammonium salt. Is that right? NH2 becomes what? NH3 plus. Again, you don't care about what the negative is. Depends on what you use. And then if you treat the ammonium plus with a base, you can do what? You can take the hydrogen plus away and convert it back to what? To amine. They can be converted back and forth. Depends on what? Depends on pH, basically. Treat with an acid, which means lower pH. Okay, more acidic is lower pH. You can get what? Ammonium salt. Treat with a base means higher pH. You can what? Get the ammonium. Have you guys learned pH from anywhere? Or heard of this word pH? What is pH? pH means acidity, right? 7 is neutral. Lower means acidic, means more acid. Higher means basic. The higher, more basic it is. Okay, the pH range is normally from 1 to 14. Okay, 1 to 14. Okay, but here, the reason I bring pH is here I want to show you is under physiological conditions. Okay, the amine can take in different forms. Under high pH, it will remain what? This form. Under lower pH, will remain what? In that form. Okay, that form. Okay, our physiological pH is around 7.35, which is slightly basic. Okay, slightly basic. All right, so that's the first part. Okay, the first part of amines are basic. Questions? Okay, next. A small part following the first part is I want to introduce you a new type of ammonium ion, which is different from something we have just learned so far. We know when nitrogen takes a hydrogen plus, again, nitrogen will have how many bonds? When nitrogen takes a hydrogen plus, nitrogen will have what? 4 bonds. And when nitrogen has 4 bonds, nitrogen will have a what? Positive charge. Is that right? This is what we have seen so far. So no matter primary, secondary, or tertiary amine, they take a hydrogen plus, they all have 4 bonds. But there's a group of molecule or type of molecule in which the nitrogen has 4 groups on it. No hydrogen. None of these are hydrogen. They're all 4 real carbon groups. We call these molecules quaternary ammonium ion. Quaternary stands for what? 4. Okay, the difference between these are the one we have seen before is none of these groups again is what? is a hydrogen. There's no hydrogen on the nitrogen. But what's same is on the nitrogen, there are how many groups? 4. When nitrogen has 4 groups, nitrogen has a what? Has a positive charge. Okay, that's why we call them quaternary ammonium ion. Cation means positive charged ion. Okay, quaternary again means what? 4 groups, which is different, which is the same system as we classify primary, secondary, what? Tertiary. But the ones we have seen before, they have a hydrogen on it at least. These guys, they don't. Okay, they don't. Okay, for example, this is a quaternary ammonium ion. Okay, you don't need to know where they're coming from. They're just know we have a lot of these existing in nature. Okay, a lot of these molecules. Okay, on the nitrogen there are 4 groups. Okay, because there's no hydrogen on it, pH doesn't affect any of those forms. Okay, you cannot play with the pH to change anything because again, there's no what? No hydrogen on the nitrogen. Okay, pH does not affect what form does it take. They're always positively charged. Okay, always positive charge. Now, why do we study that? Okay, why do we study this? Because a very important messenger molecule in our biological system contains that structure. Shown here. Have you guys heard of this molecule? You guys study AMP, so maybe you guys have seen or studied part of this. This molecule is called choline. Okay, choline. Choline is a very simple molecule with only 2 carbons basically, but there's nitrogen on these 2 carbons. It's basically ethanol, if you see that. But on the ethanol, there's a what? There's a nitrogen. On nitrogen, there's 3 extra methyl groups. That's why this nitrogen is positively charged with 4 what? 4 carbons. That's why we call this a quaternary ammonium ion. It's a very small molecule, choline. We have a lot of these in our cells. Now, on the other side of this choline, again, this is what? Alcohol. Is that right? Alcohol can make an ester bond with a acetic acid. Do you see this ester bond? Okay, COO what? R. Is that right? So basically, this molecule is, we're putting an ester group on what? On the alcohol. We call this acetylcholine. Why we call acetylcholine? Because this part is from an acid called acetic acid. Let me draw the structure for you. We have shown this before. This is the acid, by the way. Okay, we call this acetic acid. Okay, acetylcholine is basically the ester between what? Between the acetic acid and what? And then alcohol. Remember how we make an ester? You guys can repeat with me. How do we make an ester? Remove the OH from the what? Acid. Remove the H from the alcohol. Then you make a what? Okay, this is what happened here. We do this. Everyone is doing this reaction now. In fact, as long as you're alive, this reaction, making this ester bond, we're doing that every second. Which part of our cells are doing that? Again, you guys may study more about this in your AMP class. Is in our nerve muscle junction. We call that neuromuscular junction. Okay, there's a word for that called synapse. Okay, have you guys heard of this? Studied AMP? Synapse. What is synapse? This is the picture of that junction. Okay, this part is your nerve cell. Okay, this is your muscle cell. They are not close contact with each other. So that means if your muscle need to contract, need to do something, the order is not directly given from your nerve cell to your muscle cell. They're not in contact with each other. There's a gap between them. So in order to give the order, pass the message, hey, you need to move your muscle. Your eye need to blink. Your mouth need to chew. Any muscle contraction The order is given by a messenger molecule. What is the messenger? The acetylcholine is the messenger. Your neural cell releases the acetylcholine. Again, which one is acetylcholine? That's acetylcholine. This one is the messenger. Okay, the ester molecule is the messenger. And that acetylcholine is received by the acetylcholine receptor on your muscle cell to trigger a lot of physiological reactions so that you got orders from the neural cell, oh, your muscle need to what? Contract. Okay. And then sometimes we need to rest. Like I want to sleep, and my muscle doesn't contract that much. I want to relax more. Now what does our cell do? Our cell change the acetylcholine to what? Back to the choline. Remember, this guy is the messenger. So with an enzyme called acetylcholine esterase to cleave the ester bond, change the acetylcholine back to what? To choline. If there are less messenger, means what? Your muscle can relax more. You don't have to move that much. This is how it works. I mean, some basics. Of course, the real system is much more complicated than that. But it's just some basics about a neuromuscular junction works. Okay, if you want a contraction more, you need more acetylcholine. If you don't, you need to rest, you relax, you what? Our body will generate enzymes to cleave this one back to choline. Then you can have less muscle movement. Right? Now, there is a class of bioweapon that target that particular enzyme, acetylcholine esterase, to permanently deactivate that enzyme. What happens is what? If your body cannot hydrolyze acetylcholine back to choline, what will happen? You will just keep what? Your all your body muscles, including your breath muscles, will keep what? Contraction. Okay, you will never get a break, and that kills people in a very short amount of time. Okay, that's the basic mechanism of those bioweapons. Okay, you guys have probably heard these bioweapons. Okay, these are some structure of these bioweapons, including the famous VX gas. Okay, and these are some story if you want to read. Okay, some of them are actually used in real wars. Okay, real wars. Okay, because they're gas. All these are gases, so their damage is very what? Wide. Think about it. Right? So these are some stories about quantum ammonium ion. And there's a movie, guys. It's an old movie. You guys are too young to. I tried to ask this previously before we have. How many of you watched this movie? Most young kids even don't know who they are. Sean Connery is the older generation of 007, but you guys probably even don't know him. Okay, but this is the movie you can watch. It's a very good movie. And they are talking about this gas. Okay, talking about this gas. It's not a science movie, it's an action movie. It's great. All right, next molecule I want to mention here about quantum ammonium ion is this guy. Okay, this guy. This guy is a antiseptic reagent. Okay, there's a brand name is the Zifran. I don't know if I pronounce it right. Zifran, and this is the drug name. Benzalkonium chloride. Okay, what is it used for? It's mainly used for surgery preps. Okay, if you want to scrub your hand before surgery, most commonly used is the solution of this quantum ammonium ion. And sometimes they have the prep wipes too. Okay, besides most of the prep wipe you use are alcohol prep wipes. Okay, but they have this wipe too. Okay, this is the prep wipe. It's more efficient. Okay, they're more efficient. Okay, for sterile purposes. Again, also used in surgery preps. So those are some stories about quantum ammonium ion. Again, these molecules are different from the one we have seen because, again, on the nitrogen, what? There's no hydrogen on it. Okay, they're all four real carbon groups. Okay, but the same is their ammonium ion. Why? Because they have what? a positively charged nitrogen. Good? Any questions so far? Before we move on to the second part of the chapter. All right, next. Let's take a look at the second part of the chapter, amides. Okay, before we started amides, I listed these 3 types of molecules we have studied so far from chapter 5 and 6, so that you have a better picture. Okay, you actually will help you understand the structure of amides, especially after you studied esters. So take a look at this picture shown here. Okay, you can list, if I don't have my notes, you can write it down and list it too. The first molecule here on top, again, you guys should be able to recognize the functional group. RCOOH is a what? A carboxylic acid. Is that right, guys? The hydrogen plus is acidic. And also in the same chapter 5, we studied if we replace the OH with OR from what? Where's the OR from? Alcohol. Then we have a what? An ester. RCO what? OR. This is how ester is coming from. Ester is from an acid by what? Replacing the OR with what? With replacing the OH with OR. Now, if you understand that, this part is going to be very easy, at least very similar. If you replace the OH of the acid with NR from what? Amine. Is it right? What is amine? Nitrogen and what? And R. If you replace the OH with NR, you make a bond between the C and the N. The resulting molecule is called an amide. Okay, an amide. You can see that these two, the ester and amide, are extremely similar. They're both from what? From a carboxylic acid. Half of the molecule, I shouldn't say half, but part of the molecule is from what? From the acid. The other part either from an alcohol for an ester, or what? From an amine for a amide. Does it make sense, guys? All right, let's take a look. The reaction between a carboxylic acid and an amine. Okay, this is a similar scheme I showed you before in ester when we make an ester. How do we do the reaction? When you have a carboxylic acid, first remove the OH from the acid. You get what? You get that. Is that right? But remember, your C is now empty, missing something. Is that right? Because you take an OH what? Away, so you can mark it. You see miss something. You need to put something back. Then, if you have an amine, you remove a what? Hydrogen. Is that right? NH2 here now becomes what? Take a look. NH, because you take hydrogen off. Again, your nitrogen now misses what? Something. Because you have NH2 before you took a hydrogen away, it means the hydrogen missing something. The C and the N both missing something, then we what? Make a bond between the C and N, we get an amide. You guys see that? You guys see that? Remove the OH from the C and H from the N. Make a bond between what? The C and N. Okay, the C and N. This bond here is called an amide bond. Good? Okay? We can go back, but take a look. These 3 reactions. See if you can understand these 3 reactions. Again, use the logic you just put on the previous slide. Keep repeating what we just did in your mind. many times until you understand this reaction. Remove the what? The OH from the acid, the H from the amine, can be ammonia as well. Then make a what? Make a bond between the C and the N. Okay, these are 3 types of amides. Okay, 3 types of amides. Then I'll point out something. Okay, point out something from this slide. Okay, there's something missing, like hidden info in this slide. I'll point out for you. You guys understand all the reactions? All of you guys? If not, let me know, I'll explain. Okay, first thing to notice here is the amide N will always have what? 1 less hydrogen than the original what? Amine. Do you guys see that? This is not even amine, this is ammonia. Ammonia has 3 hydrogens, now this has how many hydrogens? 2. Primary amine has 2 hydrogens, now has what? 1. Secondary amine has only 1 hydrogen, there's what? There's none. Do you guys see that? Why? Because in order to make an amide bond, you need to do what? Remove a what? Hydrogen. Does it make sense, guys? First thing to notice here, I know some of you noticed, some of you not, just make it, you can make a note now. In order to make the amide bond, you have to take a hydrogen away from where? From the N. Good? That means if you have a, if you have a tertiary amine, this is a tertiary amine. Do you guys see that? Why is tertiary?
No,
Because you have 3 what? R groups. But if you have 3 R groups, then the nitrogen doesn't have a what? Hydrogen. So if you have a tertiary amine, you cannot make an amide. Does it make sense? Okay, that's first thing. You again, sometimes you notice, sometimes you not. Okay, from the slide. In order to make an amide, you need at least 1 hydrogen on what? On the amine. That's different from an alcohol. Alcohol, you don't have to worry about their hydrogen. There's always a hydrogen there. Amine doesn't have to. Tertiary amine, the nitrogen doesn't have a hydrogen on it. Good? That's first thing to notice about amide formation. Okay, or you can understand, in order to make an amide, you can only use what? Ammonia, primary, or what? Secondary amine. They're all fine. They can make amides. And by the way, don't worry about the classification they made. I won't ask you. Okay, you can cross this off. I will not ask you the classification of amides. I will ask you for amines, but not amides. Good? Okay, I will not ask you the classification of amides. Okay, we will ask amines like we did previous lecture. That's first thing to notice. The second thing to notice is amide formation. This bond is a lot more difficult than ester bound formation. It's a lot harder to make an amide bond between acid and amine than alcohol. Okay, than with alcohol, than ester bond formation. So amide bond formation, on the arrow of the reaction, I will either specify and tell you amide formation, these 2 words. Hey, I'll know you're gonna make an amide. Or you will see condition like this, showing in this book. 100-degree catalyst. You don't need to worry about 100 degree. 100 degree means what? High temperature and catalyst. These are all conditions what? Make the reaction happen. Does it make sense, guys? Again, because amide bond formation is harder than ester, you need some extreme condition with a catalyst or in your practice, in your quiz and test, I will specify on the arrow telling you what? Amide formation. If you don't see that, you can even ask me. Okay. Worst thing I will say no, you figure out there's something I want you. Good? That's something to notice here. Now, if I don't specify anything, or when you see on the arrow is not a temperature of 100, it's like a low temperature, like room temperature. For example, 25 degrees Celsius, like we're now on the room is around 25 degrees Celsius. The reaction between an amine and an acid will not give you an amide, but something else. Take a look at the products. Does any one of you understand this reaction? Something we have learned. Of course, I won't ask you something we never learned to see if you understand this reaction. Take a look. What's happening between these two? This is the temperature 25. Again, 25 is what? Mild temperature, like in our room. What is happening? Can you take a look?
Acid-base reactions that form salt.
It's an acid-base reaction. You guys see that? We know amines are what? Basic. Basic can take a what? Hydrogen plus from what? From an acid. Is that right? Is this an acid? Yes, it is a carboxylic acid. Is that right? So what happened here is the nitrogen take a what? Hydrogen plus from the acid to become what? You can see that NH2 becomes what? NH3 plus. And of course the acid becomes COO what? Minus. You guys see that? Something we just learned, right? 15 minutes ago. It's an acid-base reaction. They won't make an amide. Okay, they won't make an amide. So be careful what you see above the arrow. Okay, if you see a temperature like this, 25, again, you guys are not familiar with Celsius. You should. You will use Celsius in your future as well, because you're not art majors, you're science, you're health professionals. Okay, you will use Celsius. Okay, 25 Celsius is around 75 Fahrenheit. Okay, that's room temperature. And if room temperature, you put these two together, they will make an amide. Okay, again, like we said, if you want to make an amide, I will either do two things. One is specify, tell you amide formation. Or what? You see something like this. Okay, catalyst and a high temperature. Okay, they will make an amide. All right, so that's some hidden info to show you for the amide formation. Now I give you some time to work on these reactions. Oh, you guys done? Okay, tell me, let me take a look if you're done. Very good, beautiful.
Oh, wait.
What? Oh, that one you don't have to.
Oh, okay.
If you missed that one, it's fine. But again, you know you're getting the water condensed. I love you guys. So good. So happy you studied this way. I missing a hydrogen. See that? This one has two hydrogens, or have two hydrogens. You take one, you have to have what? One left. Okay. It doesn't have to on top or bottom, it doesn't matter. It's just, but you have to make that into an NH because you only use one of the hydrogens. Okay, here you can see that its condition here means what? You need to make what? Amide bond, right? So take a look and show me. Very good. The top, the first one. Great. Yeah. First one is great. Second one, again, like I said, you need to copy stuff. Yeah. This is CH2. Take a look. That's CH3. Copy. Sorry. It says you get hair color, you lose your glasses, or the hairstyle will cut your ear off. Like something. You have to copy. The reaction only happens on what? On the C and the N. So the rest of the world will be the second. If you drop a 2 and 3 means you're doing something reaction over there, and then it's wrong. Again, sometimes when I see those, I know you how to do the reaction, but bottom line, your product is wrong. So it's kind of torture me. Do I take the whole thing off or not? Right? So please remember, you have to copy. Perfect. Good. You're making a bond between these two. So CO, good. But what is the nitrogen? Is NH. What else on the nitrogen? CH3. What is the CH3?
Just put it right in.
Correct. Again, everything else is copy. You're only taking a what? Taking a hydrogen off and then make a bond on it. So that means that hydrogen and that CH3 what? Remains. There's no hydrogen. Take that
Oh,
hydrogen.
okay, just the H2O.
Again, you only take this away. This part of the amine will be the same. It should be the same because what you only did is what? Take that hydrogen off.
Okay.
So you should see the same thing, N, H, CH3, CH3. Make sense?
Yes.
You don't drop or add anything.
Okay.
You don't improvise.
Okay.
The same thing here. You're only doing on what? On the C. So whatever on that end of the C, you need what? Copy. Did you copy? Take a look.
No, I missed this.
Correct. You miss a carbon.
Yeah.
Okay. So again, that's what I mean. You need to be very careful on the rest of this. This is CH2. Okay. Yeah. Good. All right. Okay. Good. Again, guys. Some of you are doing great. Some of you still not forming the good habit of what? Of making copies of the whole structure first. Right? Here's the key for you to take a look. Okay, if you did right or not. Again, practice. I think a lot of you are starting to click, knowing how to do the reaction. But again, be careful. Copy the structure that are not involved in the reaction. Right? You're only changing something. Erase them, make a bond. So that means the rest of it, don't touch them. Okay, don't touch them. Okay, you're making a bond between two molecules, but don't cut the rest of the anything off during that process. Okay, be careful. Copy first, and then work on them with them. All right. So let's continue. Okay. Last time we did not talk about chapter 5 is when you make an ester bond. Okay. When you make an ester bond, when the acid and an alcohol are in the same molecule, then the ester bond can cyclize a molecule to get a cyclic ester. We call the cyclic ester an lactone. So similarly, when the acid and amine are in the same molecule, you can make a amide bond that cyclizes the molecule as well to make a cyclic amide. Okay, here's the amide bond. You can see that? And the cyclic amide is called a lactane. Okay, lactane. Okay, I don't think I will ask you to perform any reaction about the cyclic lactone or lactane reactions, but I do want to point out the existing of these compounds. Okay, what that means. Lactone is basically a what? An ester. Lactane is basically a what? An amide, but in a cyclic form. Okay, why do I point it out here? Because one of the most important type of antibiotics is a lactane structure. Okay, you guys probably have to, we'll study them, called beta lactams. Okay, beta lactam. What is beta lactam? Here's the beta lactam structure. Okay, you don't need to know why they're called beta lactam. This is the beta lactam. 4 main ring structure. 3 are carbons, 1 is the nitrogen. This is the amide bond. You can see that? Okay, why is it called beta lactam? Because this carbon is a beta carbon. Beta lactam. Okay, what are beta lactams antibiotics? These 2 types. The top one is the basic structure of penicillin. The bottom one is the basic structure of cephalosporin. Have you guys heard of these 2 types of antibiotics? They're both beta lactams because they both have what? That structure. And because of that structure actually interact with the enzyme that is responsible for synthesizing the bacterial cell wall. That's why they can kill bacteria. Because the amide bond can make a bond with their enzymes, the bacterial enzyme. So it's to stop the bacteria from synthesizing their own bacterial cell wall. Okay, that's why I want to show you these structures. Okay, these are the old generations of penicillin. And of course, based on the different R groups, we have all kinds of bad penicillins. Okay, all kinds of penicillins. And the bottom one is a newer generation for the cephalosporins. All right, so that's for lactams. And finally, about amide, before we move on to the reaction of amide, is I want to point out something you may wonder is the nitrogen of amide is nothing like amines. Or in another word, amides are not basic. Okay, even though nitrogen has a lone pair on it, but because of the CO double bond, okay, because of the CO double bond, amides are not basic. Okay, that's the only take-home message you need to know. Okay, you need to know why. I mean, we don't discuss details why, because of the CO double bond, they're not basic. But I just want to point out here. Okay, we studied amines at the very beginning of this lecture. Amines are what? Basic. Okay, why basic? Because the nitrogen can what? Take a hydrogen plus. Amides, they all have the same hydrogen, but because of this guy, they're no longer basic. Okay, that's the take-home message. Or if something you wonder, something you're given. Amides are neutral molecules. Okay, amides are neutral molecules. We will see amide bonds a lot in chapter 10. Sorry, chapter 8. 9. Okay, chapter 9. Because our proteins are made with amide bonds. Okay, we are actually built on amide bonds. Okay, the whole biological animal world is built on amide bonds. Right? So that's one thing to mention. Okay, last topic about amide is the hydrolysis of an amide. But before we start that, I put the comparison between these two molecules one more time. An ester and an amide. Okay, on the left is an ester. And when we study ester, I told you guys, when you see an ester, the first thing is to what? Identify the ester bond. What is the ester bond? The CO single bond is the ester bond. And then if you put your pen or your finger, your palm on the CO single bond, the ester bond, you can tell which part is from what? The acid, which part is from what? The alcohol. Very good. The same here. We have an amide. You can identify the amide bond first as well. That is what? The CN bond is the amide bond. Then when you put your pen on the amide bond, the part with the CO double bond is from what? From the acid. The one with the nitrogen is from what? From the amine or ammonia. Good? If you know that, the hydrolysis will be very easy to understand. What is hydrolysis? Hydrolysis needs to what? To add water. So once you identify which one is from an acid, which from the amine, all you need is to put back the OH to what? Acid. To the acid. And put back the H to where? To the amine. You guys see that? You can figure out the parent acid and parent amine for any amide. That's first important task you should be able to do. Is after you identify the amide bond, and then after you find out which part of the amide is from an acid, which part of the amide is from amine, You can put the OH back to the acid part to get the structure of the acid. You can put the H back to the nitrogen part to get back to what? To the amine. Do you guys see that? And by the way, take a look. This amine, this part is from the amine, has what? One hydrogen. You add a hydrogen, it becomes what? NH2. That's the first task. We good? Okay? The challenge part is, like I said, amide bond is very hard to make. And once you make an amide bond, it is very hard to hydrolyze. It's very stable. Extremely stable amide bond, one of the most stable bonds in organic molecules. Okay, why? Like I said, we are what? Made by amide bonds. Okay, we're constructed by amides. Nobody take a shower and then melt, right? Melt down. Right? The amide bonds are supposed to be strong, to be tough. Okay, because all animals are built on amide bonds. The proteins are amides. So, in order to hydrolyze an amide, it's not that easy like we just did, adding OH and H. That's simple to just add water, then amide hydrolyze. You have to either provide an acid or a base if you want to hydrolyze an amide. Good? But if you provide an acid or base, take a look at this guy. This is a what? Acid, is that right? This is a what? A base, is that right? We know amines are what? A base. So we do have an acid or base as a product from hydrolysis. So if you provide an acid or base, that means what? One of those two will react with what? Either acid or base. For example, if you provide acid, which one will react with the acid? The base will react with the acid. If you provide base, which one will react with that base? The acid will provide. So that means if you want to hydrolyze an amide, you must provide these two. If you provide these two, either, then one of these two products will become what? Salt. Does it make sense? You won't get acid or amine. Eventually you will get what? One of them as their what? Salt. All right? You understand that? Quickly, let's take a look. Here is the reaction adding acid. Okay, here's the reaction adding acid. Okay, I'll put the reaction on board. Okay, I want to be slow on this reaction. Okay, let me copy the reaction, show you how to do this. CONHR prime. This is what? I copy the structure of the amide. Is that right? I said first we understand this is what? Hydrolysis. So tell me, how do we
break the bond.
Perform hydrolysis? I find what? The amide bond. Is that right? So I what? Break the amide bond. Then I add what? OH back to the acid, the C, and add what? H back to the N. I change the NH to NH2 I add. Do you guys agree? Make sense? This is hydrolysis, right? But like I said, in order to hydrolyze an amide bond, you have to provide either acid or base. On the top case, we provide acid. Okay, I have acid in here. Because of the presence of this acid, the resulting amine, that is a base, will what? Further react with the acid. Is that right? How does this two react? Think about it, guys. How does NH2 react with HCl? We studied in the very beginning of the class. Is that right? How do they react? The N will what? Take a hydrogen plus from the acid to become what? NH3 and what?
Plus.
Plus. And Cl becomes what?
Maybe.
Cl minus. So if you have acid in the reaction mixture, these two are the final products. Do you guys see that? Do you guys see that? Can I see that on the screen? See, so that you can walk when you watch. Okay, perfect. It's right there. Do you guys see that, guys? Okay, if you have acid, then the amine will change to what?
Salt.
To the salt. Again, something to keep tracking the number of hydrogens. Something I noticed that before is students gonna miss. This amide on the nitrogen, how many hydrogens is? 1. In hydrolysis, you add 1, then becomes what? 2. And then further react with the acid, it becomes what? 3, but becomes what? Plus. Good? Keep tracking the number of hydrogens. Don't add more, don't add less. You have to have NH3 what? Plus. Okay, that's the top reaction with acid. Okay, let's do it one more time with the base. Okay, with the base. Again, the same. First step is what? Hydrolysis. Is that right? After hydrolysis, I add what? OH to the acid, H to the amine. NH becomes now what? NH2. This is hydrolysis. You're adding water. After that, the condition says what? Sodium hydroxide is present. So that means the acid will react with what? Sodium hydroxide. We said the acid react with base. What you do is what? Mark the what? The charge. Is that right? H react with OH to become what? Water. So the acid basically becomes what? COO minus and what? Na plus. So these two are the final products. The amine doesn't change, of course, in this case. The acid will be converted to what? To a salt. Does it make sense? Okay, very important. You will see these reactions, of course, in your quiz, and a lot in your second test. And you will see that in labs as well. So please understand the hydrolysis of an amide. You cannot hydrolyze an amide with just water. Either has to be acid or what? Or base. Okay, or base. This is, again, I show you what I did here. The stepwise scheme. Okay, first you do the hydrolysis, then you take a look at the condition. One of those two initial product, okay, the reaction will even move forward if you don't have these two. It will go back. Okay, will be converted to what? To a salt. Make sense, guys? Okay, if not, I can go back, but we have some minutes, 10 minutes, so we can clear everything out. But try this practice while you can go back and forth and see if you. Oh no, you can take. Okay, try these 3 examples. You can watch the video many times, so you don't have to worry about if the picture is not good. You're very fine, you can take. As long as I'm not in the picture, I'm good. Don't just create a media of me or something. I'm totally fine. Okay, try these 3. Okay, try these 3. And you can go back and forth and see, and I can help you as well. Try those 3 reactions. Okay, the top 2 are with acids, and the bottom one is with the base. Okay, see if you can figure out the products. Good, except that one. Okay, we miss a what? Miss a hydrogen. When nitrogen has 3 bonds, it's not positive. So if it is nitrogen plus, it has to NH4 plus. Right? Correct, because this is 2. You add a hydrogen during hydrolysis, you add another hydrogen with the acid. Correct. NH4 plus. NH4 plus.
Yeah, that's what I was saying.
Think about it. NH3 means what? 3 bonds. 3 bonds should be positive. If it is positive, then you have 1H, you have 4 bonds. So NH4 plus.
I was trying to add up.
We're recording.
What?
I heard what you said.
I said shoot.
Okay, now it's better. Because
Oh,
we're
yeah.
recording.
I know.
Fine, you're fine. You can say anything you want. We're adults.
Yeah, I go to church, I don't church. Other people may do, but I don't.
First, do the hydrolysis. Can you first tell me where is the EMI bond? CH bond is the EMI bond. So copy the molecule first. Copy this whole molecule first. Then cleave that EMI bond. Okay, do that. Copy the molecule first.
Just this part?
Yes, the molecule. Yeah, the EMI. Number of hydrogens are off. This one is correct. That one, you have what? 1 hydrogen here. So total should be what? 3. So NH3 plus. There we go. Right? This one is what? NH2. So it should be NH4 plus. So that's why I notice students are missing the number of hydrogens. Right, except the number of hydrogens. So this is NH2, right? In hydrolysis, you add a hydrogen back, so it becomes NH3. Then you have to add another hydrogen, so NH4 plus. Good, copy the structure, then what? Break the amide bond, use your eraser, break the amide bond, only the bond.
Oh, just this?
It's the bond, not break everything. Good. You're back. Back to normal. No, break the amide bond.
Oh, this one?
The bond, yes.
It's not
There we go.
really
Yes. Then everything else should be the same, H2, right? And then put an OH back to the C.
Can I erase this? Like, can
No,
I, like, just
what?
move it over?
Yeah, you can move it over,
Like,
yes.
I'm not gonna like erase it.
Yes, you can draw the bond longer next time.
Yeah.
Because usually you're gonna break it.
Right.
So you're gonna draw it longer. Then put H back to the N. So NH2 becomes what? NH3. Is that right?
Yeah.
Good. And then what? Take a look. These two, one of them will react with the HC. You're down for the first step. No, it's not, is it? Good, except here instead. Make sure put the CH3 and bond with that. Because remember the CH3 is bond. Right, don't put the
Just try to
chlorine.
put it
You can put the
before-
chlorine here. See that?
Before the-
Yeah, you can put the chlorine on the left side of the N. So now NCH3 is with what? With N. It makes it nicer.
Okay, and you add
All right, I'll do 2 with you guys. Okay, together. I'll do the first one and the last one. Then for those of you who are still not in the practice more, especially the second one. Okay. So first step, you guys, for the familiar with what we're doing so far is copy, copy, copy. Okay, copy and copy. Here, I copy the molecule on the first. I draw this amide bond a little longer than showing there. The reason is I want to break it and we'll work on that. That's why I draw it longer. You can do that too. Good so far, guys? First thing like we did is what? Break the bond only. After you break the bond, you need to put what? OH back to the C and what? H back to the what? To the N. That's called hydrolysis. Is that right? It's adding water, H and OH. We're getting now two molecules. There's no bond anymore. So we're getting what? Two molecules. Is that right, guys? And then take a look at the condition. It says what? HCl, which is an acid. Then the base product will keep reacting with that acid to give you a salt. The reaction is basically between the N and what? And the H. The nitrogen takes a hydrogen plus from the acid, so NH3 becomes what? NH4 plus, and Cl becomes Cl minus. So your final products are these two. Where this two go? This one's gone. This one reacted with this HCl now. Make sense, guys? Okay, let's take a look at the bottom one. Again, the second one is very similar. Again, keep tracking the number of hydrogens. Okay, the bottom reaction, the last one, CH3, CO, NH, CH3. Again, copy the structure first. Break the amide bond. Add the OH back to the C. Add the H back to the N. That's first step. Then take a look at the condition. It adds what? Base. So only the acid will react with the base to convert CH3 COOH to what? CH3 COO minus Na plus. So your products are these two. Does it make sense, Amanda? Make sense? Right.
Thank you.
Okay, again, keep practicing. Okay, and if not, take a look at it here. Okay, it will give you some clue. Okay, break the bond, put the H and what? OH back. And then what? Look for either one of those. Acid, your amine will become what? Salt. Base, your acid will become what? Salt. Okay, so that's for the hydrolysis of amide. Right? We're done for this chapter, and finally, before we take a break, is this chapter. Like I said, we have a lot of nitrogen-containing compounds that are used clinically as medicine already, or there are a lot of natural products that have very beneficial or some toxic biological activity as well. So in this chapter, I have 3 sections from the book. Hope you can do some reading. And then after the reading, there is a bonus quiz. Bonus, 10 points, 1 point each, 10 multiple choice. Based on that reading, I will put on Blackboard for you to take. Okay, I'll tell you later when I'll open it and when the quiz is due. Okay, 10 points bonus question, very simple, but based on the reading, your understanding about these 3 sections of the book. Okay, and before I did that, I want to give you an example showing how amazing these nitrogen compounds are and what I mean about these natural products. Okay, the picture showing here are 3 structures are very similar to each other, if you notice that. Okay, the first one is morphine, like we saw before. It is a natural product. It's not synthesized. And where did morphine come from? From the poppy of that flower. Okay, perfect. And if you guys have seen or read story about that, the white juice, when they bake it, it will become a dark, tarnish, like a paste. That's called opium. Yeah, that's called opium. And the active ingredient, of course, is morphine. Okay, it's a natural product. It's a white powder. But based on this natural product, okay, we actually can make some modifications to change the biological activities to something worse and something better, something useful. For example, this guy. If we change the OH here, the phenol group, to an ether, just add a methyl. And then we change morphine to a new medicine, a new drug. Codeine. Have you guys heard of this one? Codeine? Coughing syrup? No? This is the active ingredient of coughing syrup. It suppresses the coughing nerve. Okay. The pain-killing activity of this guy is just very weak, extreme, and also not addictive. Generally not addictive, unless you take really too much. Okay. If we change these 2 OH to a what? Take a look. What is the bond here? What is the bond here? Guys, you can recognize the bond. What is the bond? Ester bond. You guys see that? If we change these 2 OH to 2 esters, what is this? Heroin. Okay, heroines are actually synthesized from morphine. Okay, it's no longer a pain-killing medicine. It's banned in the whole world. It was actually used as a painkilling medicine before people realized human made another mistake, stupid mistake. Right, so I just want to show you how tiny modification of a molecule will change dramatically the biological activities. Right, and finally is the sections I need you to read are listed here. Okay, the numbers may be different. This is the title of the sections in your book. Okay, called heterocyclic amines and selected biologically important amines and also alkaloids. Okay, you will see that in chapter 6 of your book. Just read for the title. Your book is by sections, section 1, section 2. These are the section titles. Okay, section titles.